Good day, everyone, and welcome to Physics and Mathematics Lovers. In today's class, we are going to be discussing these two topics on measurement of heat. If today is your first time of joining us, please follow us and also do well to subscribe to our YouTube channel, Physics and Mathematics Lovers. Now, let us look at these two topics. So we said heat capacity and specific heat capacity. What do they mean? Do they account for the same thing? Now let's look at two different scenarios. Okay. When a body is heated, its temperature rises. So now, let's say for example, if I take 100 gram of copper, let's say 100 gram of copper, and also let's say 100 gram, that's 100 gram of water. All right, is heated. So when both of them are heated, the temperature will rise, but the rise in temperature in what 100 gram of copper and that of water are not the same. So they will not be the same in the sense that the nature of water and the nature of what copper differs. So now, when we look at this rise in temperature, it depends solely on the number one, nature of the material being heated. Then number two, the quantity of heat that is supplied or given to that particular system. Then those are the two things that gives rise to temperature. So now in the area of heating this and this, the temperature rise are not always the same. Now, the nature might affect it, or the quantity of heat that is supplied to that system will also affect it. Now, the nature of material is the one that accounts for what is called specific heat capacity. So, it is the nature of that material being heated that accounts for that. So, now, when we say specific heat capacity, we are looking at that amount of heat, that quantity of heat that is supplied or required to raise a unit mass of that particular body by what? 1 degree Kelvin. That is what this one is talking about. So it is what? The quantity of heat required. Let's say, for example, I have a mass of a body here, the whole of the mass here. Okay, then I will decide to take part of it and raise the temperature. I will apply the heat. That particular heat that is supplied to raise the temperature of this unit mass. A unit mass, you take what? A unit mass from what? The entire mass. You take part of it and you supply heat to it. So this particular heat that is required to raise this temperature by 1 degree Kelvin is called specific heat capacity. And now, if we say that this body having a mass m, if it has a mass m and temperature that is required, we also have the temperature which is called theta. So now, if theta 1 is the initial temperature of the body, by the time it rises, it will get to theta 2. So this is the rise in temperature, and the rise in temperature is what? Theta 2 minus what? Theta 1. So now, what is the quantity of heat that is given out here? The quantity of heat that is required now is calculated by what? Q equal to the mass of this body times the specific heat capacity of the body and what? Change in temperature. Change in temperature is this. This is a change in temperature. Because when the heat is applied to a body, the temperature must rise. That is what happened. So this specific heat capacity here, this is the specific capacity. How do we calculate it? So just divide both sides by the mass and this. At the end of the day, you're going to have your C, which is the specific heat capacity, there, all over. That is all Q. Okay, this is Q, the quantity of heat divided by mass, then temperature change. Okay, so which means for us to get the units of this specific capacity, so we know that what the quantity of heat is measured in joules. Okay, if the quantity of heat is measured in joules, and here we are having kilogram, then change the temperature. Temperature is measured in Kelvin. So we therefore say that what the unit of specific capacity is joules per what? Kilogram, joules per kilogram, then per what? Kelvin. So this is what the unit is all about. So that is for what? The case of what? Specific heat capacity. What is now the heat capacity? What is the difference between heat capacity and the specific heat capacity? Now, the heat capacity of a body is the amount of heat that is required to raise the entire mass, all of them, the whole of the body, by that same degree temperature, by 1 degree what? Kelvin. What does that mean? So we have here, let's say for example, the body is this. The given mass of the body is this. Let's say the whole of the mass. So what will happen is that what? I will supply heat to raise the temperature of the whole of the mass, the entire mass of the body. So heat capacity is the quantity of heat required to raise the temperature of the entire mass of a body by 1 degree centigrade. Now, or by 1 degree Kelvin. And it is denoted by what? MC. Heat capacity is denoted by what? MC. Right. So we go back to this same formula. When we go back to that same formula, we have that what the quantity of heat now to raise the entire mass of the body is given as what? MC theta. So this MC theta, this theta is now the change in temperature. So let's put it here. Change in temperature, because the temperature must rise. So in this case now, MC is the what? Heat capacity. You can call it heat capacity or thermal capacity. So which means what? Our MC is now equal to the quantity of heat all over what? Change in temperature. So this is a change in temperature. That is what? Quantity of heat given or supplied all over the change in temperature. So since we said that what? Heat is measured in joules, that is the unit of heat, all over temperature is what? Kelvin. Therefore, the heat capacity MC is measured in what? Joules per Kelvin. You see the difference now? So the difference is just one, you require what? Just unit of the mass. Just take part of the mass. Then while the second one, you take the entire mass. You raise the temperature of the entire mass. So the same quantity is supplied. But the only difference is just at the mass. So if you find this class very interesting, do not hesitate to share this video, extend this knowledge. So in our next class, we'll be doing calculations on this topic. Bye.